Back to Deep Thoughts, ladies and gentlemen. It's a lot of my Babalu. It's like a Cameroon, Connecticut, Maduro wrapper twist. As you can see today, we're going to talk about crap science. And you know, if you watch all the shows, you know I talk about this kind of stuff off and on. But I thought what we do is put down our own science on top of it. Meaning, how do you define crap science? Because I'm setting up the gear today and I'm kind of excited. It's a really beautiful day. Studio's all clean. The only thing unattractive is the hose here, which I can probably put away because the little dog that lived next door moved away. And if he started barking during the show, I'd just spray the tree in my yard and that'd freak him out. The sound would freak him out and he'd go inside. It's really cute. But crap science is, here's how I'm going to define it. We should probably come up with some levels. Let's just make it up here. Let's just say there's a level 3. I don't think we need to go any higher than that. But level 3 will be the most pure form of crap science. Our measurement will be this. No matter how many years, decades, and centuries that you apply yourself to a particular level 3 crap science, you will never ever find anything because you are so full of crap that all you're doing is reiterating bullshit in your brain. You're so off base from how the mechanics of the universe work, it just won't work. And we'll let level 2 arrive when it arrives, but level 1 would be, well, you're sort of getting warm, or you're sort of warm, or you know what, you could eventually find the right path because it looks like you're not so completely indoctrinated and confused that you're going to stick in this crap science. Level 3. Level 3 crap science would be someone who's also so embedded, so invested in shit science that their ego and their self-image and perhaps their accolades from the outside world, their awards for what they've done, are so tied up in it. There's nothing they can do to pull out of it. They have thrown down the law in their own brains. Now, the saddest part is that people who believe that sort of thing, like a Neil deGrasse Tyson, I don't know what he believes. Science guy, who fucking cares? That guy reads from a script 24/7. But let's say a Neil deGrasse Tyson. He's got a PhD. He's Dr. DeGrasse Tyson, whatever. He seems pretty confident in his spiel. But I mean, the guy walks in the room and people just fucking cower down because they have no knowledge in his area of expertise. The other thing to do is back up on that guy's career. He's not a Hawking, people. He's not known for revolutionizing a zero-point energy system, and now he's just fucking around on Zoolander 2. But simply go on Joe Rogan, go on some show and say, you know what, guys, I think we've had it wrong. And I think that, I realized I just learned what I was taught in school. And I was really good at memorizing things and deducing things. And so I got famous for regurgitating a bunch of crap that I really never checked out. I never really thought it through and said, does this really make any sense? And when I decided it didn't make any sense, I changed my loyalties in this world to, an unadulterated avenue of information. And I've done my own research now. I've worked with people 10 times as brilliant as me who aren't on TV. And I realized that I had a bunch of things mixed up. And the most exciting part is, holy shit, I think I'm on the right track. I figured out gravity was a push, not a pull. And it's just opened up the entire universe. I figured out the universe is made of electricity based on ethereal winds. And boom, my brain exploded. And now, what is he, in his mid-50s or so? He gets to start over. He gets to start over in a super exciting world instead of waking up every day in some, I gotta pretend I know this and I gotta regurgitate that. Nope. He's totally happy and he's totally renewed. So that's the benefit of coming out of crap science. You're only getting accolades by other fucking idiot people. So what? So everyone who's stupid, literally in the audience? I mean, you want to have a stupid filter? Put it on an audience. Just say, raise your hand if you think Neil deGrasse Tyson's right about all the stuff that he says. Majority right about everything he says. Raise your hand if any one of you thinks that, Bill Nye the douchebag guy is a real fucking scientist. Second the hands go up. Boom. There you go. There's your fucking idiots in the crowd. Now again, children don't know anything. They can have shit parents who don't teach them anything. So we're not talking about kids. We're talking about grown adults who should know better. But I thought I would take some of the theories that I piss on in this show as being fake and slow it down, talk about it in a little bit more detail. For you, those of you who aren't into a lot of the science details, this might be a little boring, but I think that I'm going to try to do my Richard Feynman impersonation, which is to say, I won't speak in a Brooklyn accent, but I'm going to try to make this understandable by everyone, or for everyone, right? The first one we want to go at is the Big Bang. As I always say on the show, the Big Bang was a wonderful theory that allowed housewives in the mid-60s, or I should say late 60s, early 70s, to believe that they understood how the universe was created. And I say housewives not to demean women. I say that because we had a balanced family unit, and the mothers took care of children. They had educations. They went out and got amazing jobs after their children started going to school, taking the bus. But they were busy working on kids. They weren't the men that went out and had no choice but to work and work and work and become scientists and aerospace people early in life. So even our most incidental minds at the time, or that stage in their life, could totally understand how the universe was created. And that feels good, right? I do believe that once we do figure out the fundamentals of the universe, we can explain it to each other through a 5-year-old. I can whisper to my 5-year-old, and he can walk across the street or walk across the room and talk to mommy, and he'll say the right thing on the other side, and mommy will understand whatever it is, and vice versa. I keep waiting for that 5-year-old prodigy kid to solve all of our issues. Boy or girl, I'm in there. Joseph Campbell was a philosopher / I think, anthropologist who studied the inceptional mythos of man. What does that mean? He went around the world and tried to find the earliest stories that man told himself about how the universe works. Spiritual beliefs, burial beliefs, right? If you believe there's life after death, then you have to have a model in your brain for what that is. You don't have to, but everyone seems to find one, right? So we know that the indigenous South Americans, before the conquistadors came over and crossbred with everyone, they had their own belief system. The Aborigine had their own belief system. All the African sectors had their different ones, etc., right? So he started doing interviews and stuff very early in his career, and if you want to really, he's very slow in his tempo when he does his presentations. You have to be prepared for that. But he is a brilliant man. He's dead now. He was a huge contributor to Star Wars. Even though if you watch Seventh Samurai, you will find out that storyline was really old. But he helped George Lucas put it all together. Those of us who write screenplays, you usually get into Joseph Campbell at some point. But one of the best presentations he ever gave, and I don't think that he actually did what I'm about to do and what I've always done, which is compare it to the Big Bang. I'm sure he thought of it. Just didn't quite want to get into the controversy of it in his class. I believe I have this correct in that he said that South America had the story, and Africa had the story. And that is that when God, before the universe was created, God was asleep. And then God woke up. And when God woke up, he exploded. Which is what a god-awful way to fucking wake up. He explodes, and his body creates the entire universe. Now, there's a difference between the two stories, but the difference only happens after the explosion occurs. In one part of the story, in one version of the story, the planets and the stars already exist, and it's merely the life force that is us that lands on these particles called planets and stars. And I really feel sorry for our cousins that landed on the star. But that's how we were created. Now, the revision to the story is that everything, the stars and the planets and the moons and everything, and us, came out of God. So it was all just sort of meant to be. We're the exploded guts of God. How beautiful is that theory? But that's one of the earliest tales of mankind trying to explain what the hell happened. It's actually, depending on what year that story was told, and we don't exactly know when the story originated, to my knowledge, it's brilliant to think that someone would look at the stars and find splatter instead of diamonds in the sky. You know what I mean? They said, oh, that looks like when I dropped that bowl of milk and it splattered on the wall and there was a bunch of dots on the wall of milk. And I thought, oh, wow, dots, explosion, crash, boom, bam, right? Interesting, right? So now we got to jump into a little bit of science. Now, gravity is at the very core of this argument, the definition of gravity. Now, crap science has gravity as a pole phenomenon. Go look it up on Wikipedia in 2018. If you're 100 years from now, then it's probably been corrected, hopefully. But gravity is not a pull, it is a push, and we'll get back to the push in a second. But scientists said, oh, we understand that mass attracts mass. For those laymen out there, well, it just means if you put two bowling balls together in space, they're going to bang into each other. They're going to suck towards each other. If you put a marble and a bowling ball, well, the bowling ball is going to pull heavier on the marble than the marble pulling on the bowling ball. But eventually they'll get together. The smaller unit is going to be subservient to the bigger unit because there's more pull, supposedly. But pulling implies what? And pulling implies that within the atomic energy of something, that there's this magnetic attraction between them. But that also suggests that there's some sort of communication between all mass and the universe, that somehow this, the mass in this little microphone stand here is talking to the rings of Saturn somehow. As infinitesimal as it might be, they're talking to each other. They're exchanging information about where they are and thus creating some sort of sucking thing, a pull. Now we know that in all of our research of slamming protons against protons and giant accelerators, we're not finding any evidence of that whatsoever. We still see gravity work. We see when things collide and they spin off from each other. Sure. Well, look at that, a spiral thing. But when you take a step back from that as a objective scientist and you go, that can't be. That can't be the case. Now, for those of you who've dove deeply into electrical universe, you might be thinking, oh, but it totally is. It's an ecosystem of Van Allen belts communicating with Van Allen belts, and they're all kind of holding each other together. I don't disagree, but you need to understand that's the other theory. Okay? Well, one of the neat exercises we do in science, and again, I don't blame someone for going down the path and looking at a Big Bang Theory and a really quick exercise, but at some point, instead of getting goo-goo-eyed over your theory that is based on crap, you pull out and go, oh, that was cute, but it doesn't work like that, so this theory is kind of stupid in the first place. But here's the way the Big Bang Theory works. For those of you who've never had it explained to you, I apologize for those of you who are into this, but you're going to like the rest of it. If all of the mass in the universe pulled on one another, I mean, if you had just two atoms in space, they're going to start banging against each other. then what would be the overall eventuality of the theory? And a lot of this, I want to bring in this analogy because it's a very important, fun little analogy, which is, when you get some sort of equipment and it's got a bunch of knobs on the front and you're not quite sure what the knobs are, it could even be software. And you start playing around with it and you want to know what a particular knob does. What do? We all do the same thing. We turn it way up and then way down, way up and way down, because then we're hearing the difference, right? Because that allows us, that makes it clear. That makes it really muffled. That's really weird. Look at the bass. The bass goes really up. The treble goes way up. Okay. So the Big Bang Theory is someone coming up with the basic theory of a pull. And hey, supposedly it was, the theory is credited to Isaac Newton being occasioned by the fall of an apple. The cartoon story is that he was hit on the head by an apple. It's kind of funny. So he's sitting in an apple orchard watching things fall. Supposedly he's the first person to ever think about it. But then again, he's British, so it's about a 99.9% chance that story's a lie. But they took it to 11, didn't they? They turned up the knob as far as they possibly could and said, well, what would happen if everything pulled on itself? Well, eventually, would it be logical that regardless of how large the universe is, at some point it would all pull on itself? And it would all pull itself to a single point in space-time. Everything would be yanked back to some center point, which on average would probably be about the last time this ever happened, because there would be sort of like the center of gravity to the universe, from where the original explosion occurred in their theory. And again, the idea is that we actually understand the dimensions of the universe. Like, we understand how big it is, There's all these theories I've heard since I was a little kid. Like, I think by 1982, my uncle told me, well, they think the universe is the shape of a shoebox with a sinking lid. And you're just listening to this shit going, oh. And even as a little kid, you can feel the truth a lot easier. Obviously my uncle's just repeating what he had heard from someone else. And I'm just looking at him like going, well, we know that's bullshit. It's like they don't have any fucking clue how big the universe is or what shape it's in. They don't. Just because your telescopes can't see any further doesn't mean jack shit. Right? By the way, I meant to say the other day that the amount of telescopes that we have, especially the big radar arrays in the desert, especially the Vatican's Project Lucifer array, the lack of images that we see from these telescopes is almost absolute now. When I was a kid and they started building those things, we used to get all these pictures. Having just bought, all those rags I told you about at the airport, I'm not saying anything. I can buy an astronomy magazine, and just the deep space crap we're seeing is sort of the Sophia project. So, I don't know, which is the real thing, that's the Hubble telescope. Not seeing all this crazy, amazing shit. So, either that stuff doesn't work, or they're hoarding it, like usual. But the idea is that this mysterious force continues to work until it pulls the whole universe into what they call a singularity, which is that it is the teeniest, tiniest little thing. And we're talking about, it has, according to, and this is where it gets romantic, this is where scientists, god damn, it's amazing the balls these guys have, or the lunacy they have, or both, where they tell us that everything in the universe is crunched down to a pinpoint in space that is so teeny tiny, it essentially defies all physics, because that's smart when you're trying to prove your own discipline, that it has no mass. It occupies no space. It is the most infinitely small thing. And it must reach this pinnacle, teeny tiny pinprick in space-time before it can explode again. Pulling and pulling. Because if you have a pull model, you don't need any external force on anything. And you perceive the atom as pretty much the grand object in the universe. And if you start doing, subatomic physics, you'll get into quarks and muons and gluons and all this crazy shit, right? The God particle. And then miraculously, at the point of absolute perfection, when this thing is compressed down to be absolutely perfect, and remember, they're not theorizing any air bubbles in it, any warts on it. It's not a bizarre, medicine ball thing. It is 100% perfect. It explodes. And when it explodes, well, this random chaotic universe happens, which is where the Big Bang Theory completely defies itself. Oh, this perfectly symmetrical object explodes in the most uniform mathematical way possible, but what we get is an absolute random universe out of it. Uh-huh. Yeah. No one ran Mathematica on that little model. We have life, right? We seem to have chaotic, ever-renewing patterns in the universe. Stephen Wolfram's research, and that we probably have somewhere between 2 to 3 unique particles in the universe, or categorizations of ethereal winds, and then we get pure chaos. Pure. Steve Jobs once went up to stage when he was talking about the iPod. I maybe even just been talking about iTunes. I think he was talking about the iPod, though. And he was talking about the shuffle feature on an iPad, which is where it randomizes what you hear on your iPod. And he said, creating random numbers is really tough. We've been doing it for years in video games and all kinds of simulation software, but he goes, we discovered it's really tough. And when we put it on a musical playlist, we realized that even if you have 1,000 songs on an iPod, you're hearing the same song within a few hours. And so he's like, well, we worked really hard to make it more random. Because random ain't easy, baby. Right? Yeah, I will tell you this. One of the first things I ever programmed in high school, I should say first, but probably the second term project I ever programmed for another person in high school so they could pass class was a poker game. And I had to shuffle 52 cards from a normal deck of cards. And the amount of random features that were in computers were pretty primitive. I was on an Apple II computer, Apple II Plus. The kid actually failed, not because the software didn't work great, but because my teacher could smell my code. It was funny. But it's an eye-opener. It's a freaking eye-opener when you have to really make sure that the user feels like something's random. So anyway, we got a random universe out of it. We got a chaotic universe out of it, which means that the very theory itself, regardless of how much you want to mulch it and modify it, it's not true. The gravity ain't a pull, it's a push. And that's the first thing you'll learn when you come out of it and go back to the original theory of gravity. When gravity is a push, the theory completely falls in on itself. And there's some beautiful regulators when it becomes a push versus a pull. In a pull algorithm, you could actually theorize the creation of a singularity, which in its infantile stage of becoming a singularity, you have things like black holes that they use to scare the shit out of all of you guys, right? Oh, a black hole's gonna swallow up the universe. It's gonna be a bunch of black holes floating around the universe, and they're all gonna, collect to each other. And let's take a little diversion into black holes before we get back to what would be the limitations on a Big Bang theory with a push ethereal model of gravity, which is essentially creating negative pressure pockets between ethereal winds. I should say we use wind because it's a theory that we can all wrap our minds around. It most likely isn't necessarily a wind, but it is an ambient three-dimensional force of moving subatomic, or I wouldn't even say atomic, but subparticle theory. And we'll get back to that. But a black hole is said to be theorized to be possible to exist between a star that is 4 times as large as our star. That's the minimum amount it would take to start creating this black hole, this singularity. Before that, if you're mass 1 through mass 3.9, you're going to get a brown dwarf, neutron star. So it's going to collapse, but it won't be able to collapse to the point where it can swallow up the actual verbal reaction that is photons, right? When photons try to come off of agitated thermalized matter, it only has so much force to wiggle itself away from its source that's creating this reaction. And at mass 4, they've theorized on paper that the photon ripple, which is like, again, when we throw a rock into a pond, the ripples are the photons. So when I say, go get me some ripples, you look at me really funny. And that's how it should feel if you're a physicist and I say, go out and get me some photons. You can't harvest photons. You can only create them. You can control them, right? I can control ripples in a bucket of water with my hand. Just keep tapping it and create as many as I want. Sort of what an LED does. But it can go all the way up to, I believe, a mass 12. So 4 through 12 gives us 8 units of size. And once you go over 12, the mass of our star times 12, you start getting such an explosion when it comes together. The theory is that it'll just keep collapsing and exploding like a mini Big Bang. Now, what's interesting is both the Big Bang and black holes have, if you talk to decent physicists, they have atomic limitations. The way that they have actually started to dialogue about this about 40 years ago that I know of was to say, okay, let's take time as a mechanism to study the physics of what would be happening in one of these bone-crushing pull theories of mass. And so they'll get down to the point where they're dealing with a nanosecond of time within the Big Bang. So we've got it kind of theorized down to the last 800 nanoseconds of the singularity creating itself before it explodes. But we can't get, the physics starts to break down. We can't actually allow particles to do this because we know they don't. Because we look at experiments in the laboratory. As it is above, so too it is below. But they just go ahead with the theory. Well, we'll figure it out eventually. I mean, we know we're right. Shit, even though nothing actually matches reality, we're making a lot of money off this, right? For those of you who know Douglas Adams, it's a bunch of majig thighs talking to each other about the answer. You just make it up. Bullshit yourself. So the black hole is very similar. The black hole starts to create, and it's funny because it's been different a million times. When it first came out, in the 1770s, I believe, it was a ball that was going to trap light. And then it went to an Einstein-Rosen bridge where it became this funnel, like in the movie Black Hole by Disney back in 1978. You could drive through it. And we've seen that, every other movie, it's got like a funnel. And you're going to go into the black hole and you're going to pop out in some other part of the universe. And the Einstein-Rosen bridge theory was invented because it sort of throttles the problem of a crushing bunch of mass energy. When time ceased to be an illusion created by perception, which is really the beauty of general relativity, they started treating it like it really exists. And it doesn't really exist. I know that sucks. In your brain, you're like, fuck, it does exist, man. I was a child once. It's like, yeah, you were. But that's just your perception, man. I mean, it's just your perception. So when they started playing with space-time, they started saying, well, we can create all these dimensions of when shit is. And this is where you start to get wormhole theory. And it's not like a wormhole can't exist, but the idea that simply because mass hits a point where supposedly the gravitational pull is so heavy that it keeps photons within some orbital loop such that no one can see it outside of it. Now, the thing is, if you got right up on a black hole and go inside the event horizon, it's going to get bright as hell really quick because all of the ripples of photons are going to be in this bubble. It's going to be super bright when you get really close to it. By that time, you're going to get sucked into it if it's truly a pull. So all this mass comes together, and again, the shapes have changed, but if we just get rid of the Einstein-Rosen bridge sort of sci-fi television funnel thing and go back to a ball, or what eventually was theorized in the 80s, which becomes a disc. It really becomes like a flying saucer looking shape. Because it's spinning, the inner equator is the plateau. It becomes that saucer-shaped edge. And right on along the edge, something magical starts occurring because this is where the photon can escape. And this is where physics got it's really funny. They get to a point where they create a playground where they can bullshit about absolutely fucking anything, and no one can argue with them. Stephen W. Hawking can take it all the way to the edge, and because he's brilliant at theories on paper, they started saying that, antimatter is created at the very event horizon where mass and energy, its very fundamental components, are ripped apart and antimatter starts creating itself. All right. They could say Teletubbies start creating themselves at the event horizon. And what intellectual means do you have to argue the theory against? And here's one of the bummers about science, okay? And it's not necessarily a bad thing, but let's say you're enjoying your life. You live in these backyards like I do, and you're just having a good time with family and friends, and some dude comes around the corner with a bunch of pocket protectors and broken glass with tape on them and a notepad and his little fucking iPad he's drawing on, and he's like, oh my God, I just theorized we've only got 5 minutes to live. And you're looking at this guy going, what? Oh my God, it's horrible, sky is falling, I'm Chicken Little. All right. And he freaks out all your guests, and they all run home. Thanks, asshole. So what is this theory you have? Oh, well, it's taken me years to come up with this theory. 5 minutes goes by and ain't shit happening. But now you got to go walk to all your friends that left your backyard from the barbecue and go, look, this guy was fucking bullshit. Remember he said 5 minutes, and look, it's fine. You feel okay? All right, this guy's full of shit. And that's the average science community today. Look at me, I'm important, I'm a fucking nerd. It's attention-getting shit. It's no different than the people who say they're psychic, but they can't predict a goddamn thing. So the black hole theory continues to evolve. And again, it's a mini Big Bang, really. Because eventually what they say is, okay, I said that there's limitation between 4 and 12 of you take stars that are 4 times as big as our sun to 12 times as big as our sun, and all by themselves. Eventually they lose their atomic ability to be stars, and when they start to collapse on themselves, they don't supernova, they just become black holes. That's the theory. So that's not exactly a benign thing in space, right? It's going to have a huge gravitational pull, because we have this pull theory going around, and so it could drive by one of our solar systems and it would suck us up in 2 seconds, eat our sun in fucking a flash, and we would literally, Earth would just disappear in a matter of seconds, if not nanoseconds, right? Ripped apart. Oh wow, we've created a supervillain in the universe now. But they continued the theory and said, well, what if you had 2 black holes, 2 mass 12 black holes bumping into each other? What would happen then? Now, the true theory of this is that if it does maintain a disk shape of any kind, its rotational speed would be out of this world. Probably way faster than the speed of light. And so when they bang into each other, it's going to be a light show. It's going to be amazing. They're going to combine. Now you're going to have a mass 24 black hole. And that theory just keeps going until the harbinger of all, Big Bang Theory is going to be a bunch of these things banging into each other. But someone had some balls in the late 80s and early 90s to finally do the math on this thing, these black holes, and said, you know what? I don't think it's going to do this. I think the way that mass in a pull model of gravity attracts itself will start to create a funnel in the center of this disk object. So instead of having a nice bubble over the center of our UFO, it's going to create literally like a cone going down into the center, and there's going to be one on the bottom because it's equal top and bottom. Physics is fairly unified in its behavior. The mathematical models that hold it all together. And then what's going to happen is it's going to create a little funnel such that everything that's vectored down to this is going to spew up and spew down, way outside of this black hole, and it's going to create some super heavy elements. I think they were talking about like helium-23, which is an extremely heavy version of helium. There's a lot of theories about what atomic elements it would create. But very quickly, as soon as it created itself, it would diffuse itself back into the universe as this heavy element just floating around space. Because the velocity would be so absolutely heavy, the amount of distance that stuff would travel at the top and bottom, it would be very difficult for this mass to find itself again in the universe. Again, it's all just theories on paper, people. So what's really interesting about it is that the same exact science, the same exact theoretical physics that punched a hole in the black hole would apply to the Big Bang. 100%. But now what if gravity is a push, not a pull? Now, if you want a 1-hour detailed episode on gravity, go look at it. Just look up gravity on this channel. And for those of you who don't know how to search on videos, you go to the channel on YouTube, or you go to the website, deepthoughtsradio.com. You go in the search field, you type gravity. On YouTube, you've got to click the channel homepage, and then you get the search field, which searches within my channel, and you type the keyword, and you'll find it, right? But what gravity, I think, really is, because it starts to solve all of our frickin' problems in physics, it no longer is a phenomenon, is that we have this stuff called ether. It is the only particle that exists in the universe, period. Everything that you see is nothing more than classifications of how this stuff behaves, right? As I've said several times on the show, if I point to a spinning vortex of water and I say, "What is that?" And you go, "Oh, that's a vortex of water." And I said, "No, it's just water." Then you look at me and you're like, "Well, you're just an asshole." And I say, "Well, you know what, I could be asking you how that behaves, or I could be asking you, what is that?" The what is that answer is it's water. The how it behaves, it's a vortex. And so that's how we come up with protons, neutrons, electrons, everything in the universe, even a quark, is all how this stuff behaves, how it spins in space, how it entangles itself in space, such that you can say, that is a proton. That is a photon. Photons are more elusive because, again, just like in the ripples of water in a pond, it's still water, but it's also ripple, but you can't go get the ripple. And ripples only exist for a certain amount of time. Why isn't the universe completely white? Because we can't get all of the light being created in space from every single angle, because it does cancel out, it does get weak, and it does go away. When we have telescopes with bigger lenses and cameras with better, CCD bladders or whatever, they can grab more light, and then we see deeper into space, okay? But we see gravity in our Cheerios, don't we? When Cheerios float on the surface of your milk in your bowl, you'll see them go dink, and they attract to each other. You put your spoon in there sometimes, and it tracks. Now, there's a water tension issue to that as well, but you'll see it go to the edge of your bowl and hang on to the bowl edge. Again, a lot of that's water tension and the curvature of the tension on the water, but a lot of it has to do with, relatively speaking, in a two-dimensional Cartesian coordinate system, a two-dimensional plane, gravity is able to demonstrate itself right in front of your face. The Earth attracts the moon because the Earth is blocking the winds of the universe from its backside, such that there is a negative pocket of pressure between the moon and the Earth. And so the moon is forced, because it's getting hit from its backside in every single three-dimensional angle it can, towards the Earth. And the only place where there's a negative pressure, meaning a little less push on the moon, is between the moon and the Earth. The Earth rotates around the sun because there's a little less pressure between the sun and us, and that's how everything holds together. And I wanted to say publicly, for those, and I went down with this in one of my episodes of Flat Earth, but one of the most fundamental things you start thinking about gravity is that it's just air pressure, that we're inside some snow globe and it's the air pushing down on us, and that's why we're pushed to Earth. The proof that that's not the case is that when they take a glass container or some plexiglass container so we can see inside, and you put a feather in there, and it goes to the bottom of the container. You're like, well, of course it does, because air pressure in the container is pushing that feather to the bottom. Okay. It's inside a vacuum-sealed chamber, and supposedly there's orientation down. Well, if we seal that chamber up, then what's holding the air down, right? So that's the first proof that there's something passing through the chamber that's creating orientation to the bottom, to the Earth's surface, right? But then we can easily vacuum out all the air out of the chamber, and the feather still stays on the bottom of the chamber. It falls a little faster because there's less air to bump into as it's falling, so the feather will fall like a paperclip inside a vacuum, but it's still falling down. And that's because ether exists. Ether is so teeny tiny and moves at 50 times the speed of light that it travels through the container and pulls it down. Why is it getting pulled to the bottom of the container? And why is the container holding to the table? Why is the table holding to the ground? Because the Earth is displacing all of the ethereal pressure that would push it off the surface of the Earth, because the Earth has got so much mass, so much current, right? Spinning currents, right? Just like the drain in your water, that it is having more pressure push on it down than can push up to make it levitate, because the Earth is so huge. The Earth is still permeable to ether, meaning ether can go straight through the Earth in all directions, but there's more pressure pushing down than anything pushing up, so it wins. Right? When you have someone arm wrestle with someone else, well, you still lose if you lose, right? You still win if you win, but they're still pushing. The loser is still pushing back, but their arm is pegged on the ground, right? Why is that? Because the arm that's winning is a hell of a lot stronger, right? A lot of you will know that they have revealed off and on about every 20 years that there's this mysterious force that comes out of the Earth, this mysterious anti-gravity force that comes out of the Earth. But they never explain it. And it is two things. It is I would say the dielectric energy force, where ether's coming down, bounces off the Earth, and comes back up. It's very minimal, because most of it gets absorbed. And it's the other ether that goes all the way through the Earth and comes out the other side. It's very, very light. It is the losing arm wrestle person in this equation. But how can a singularity exist, and how can a black hole exist if it's all a push? Well, in a black hole, it makes a little more sense that you could get something kind of like that, because you'd have a bunch of ether around the black hole. There's still a bunch of stuff out there in the universe. And maybe a current can get so intense that pretty much light gets stuck in some orbital pattern. But again, you go back to the liquid dynamics of mass, energy, and you're going to get this dissipation thing that Stephen Hawking talked about. But when it comes to a Big Bang, now you got a big problem. How does all the mass in the universe get compressed into a singularity when you need the mass of the universe / ethereal winds to push it into that spot in the first place? There's a circular logic problem here. You can't have a bunch of stuff outside of all the stuff that's inside when they're supposed to be the same exact thing pushing on this object. With the pull theory, you can start to compound the force, because you're accounting for everything coming into this little tiny spot in space, and it can get stronger and stronger and stronger because the force is within that singularity. It is creating its own force. When you go to an external force of gravity, you can only put so much stuff in the middle. So much current could exist in the middle, and then it's just going to sort of top out, because how does gravity work in a push model? Okay, well, you certainly have a certain amount of volume of displacement, right? So you have a diameter volume of displacement. It could be a pretty weird looking asteroid, it could be a perfect circle like the Earth. But then there's the density of the object that also controls that permeability. We talked about the feather in the container and the fact that I'm sitting in a chair. If Earth was mostly like a gas inside, there's no plasma core that holds off ethereal winds, then we might be on sort of that fake moon footage, right, where we're all kind of floating around, right, because there's still a lot coming out from under the bottom of the Earth. And so we kind of weigh a pound for every 100 pounds that we weigh. We're like Superman. I could just jump to the beach. Doesn't mean it's going to happen really quickly, but it's like any one of those video games where you kind of get the flying feature, the little bit of gravity. But thank God planets are the way they are. Now I'm tempted to call this the Big Bang episode, which I wanted to do, but here's the thing. To go back to our crap science meter, if you believe in the Big Bang and you believe that gravity is a pull and not a push, you can study it your entire life. You could live to be 200 years old, and as long as you are a closed-minded scientist who's trying to impress the ladies with your pocket calculator shit, you're never going to find the truth because you're so off base. And there's going to be a singularity of humility once you finally pull your head out of your ass and figure out that gravity is a push and not a pull. But when you get a bunch of trophies and awards and accolades and you get to speak at various meetings and people are like, oh my God, he's so intelligent, for believing the wrong thing, man, trying to pry that out of the hands of a scientist is the heaviest form of gravity you'll ever find, right? So in electrical universe, which I mentioned at the beginning of the episode, all of the paths of electricity and anything is designated as some sort of fundamental energy of the universe is literally dictated by these ethereal pockets of positive and negative pressure. The magnetic poles that come out of things, the electromagnetic poles that come out of things, it's all controlled by the various properties of ricocheting mass. You know what a ricochet is. You shoot a bullet, it hits something, and it bounces off. That's dielectric energy. And then you have your orbital patterns of behavior, which is where you get your electron clouds. You get your moon and your earth and your sun. One of the worst things that happens in crap science, and it's sort of tough in the past, but now it's really easy with 3D software, is that all these three-dimensional concepts have been portrayed as two-dimensional objects in paper diagrams in your science books. And so everyone gets everything off because we haven't advanced the intellect of man to think in three-dimensional space, unless you're a special effects person or you're dealing with a lot of simulation software. It's one of the beauties that Stephen Wolfram's application Mathematica has allowed scientists to evolve their brains to think of things in 3D. I'll give you a really funny story. One of my close friends is Sid Mead, SYDMEAD.com. Go check him out. He's a futurist designer. He has designed movie after movie after movie, but he's also designed objects. He's done planes and yachts and cars and your television sets, but he's done Blade Runner, Tron, Star Trek, Aliens 2, Short Circuit Robot, on and on and on, Elysium, Tomorrowland. This guy's on fire. He did Las Vegas, Blade Runner 2049. He's a genius. He paints in watercolors. He draws with a normal pen on paper. And one of the things those of us who are close to him have figured out is that Sid thinks in 3D. Sid has played in some 3D applications in his lifetime, but he, to my knowledge, hasn't ever really created a finished product of 3D. Meaning, hey, I did my latest vehicle design in 3D. He has people like me that will do it for him after he creates the top, bottom, left, right, front, back illustrations of them, right? But as an industrial designer, I've seen people who are, famous for the exact same thing. They're the top Ford designers, the top whatever designers, other movie designers like Oliver Schul. And they'll look at me and they'll go, that dude has been thinking in 3D since he was without exaggeration, in his probably late teens, early 20s. And it was that perception that Sid had, that ability for him to hold a model in his brain in 3D and never forget, I brought that tube over the hood, right? If he was designing the DeLorean and Back to the Future, okay, he would remember where every single switch and knob was. You could rotate it in 3D, and he likes to design things asymmetrically, meaning left does not match the right, top does not match the bottom. He loves that because that's more organic and more believable. It is that method of thinking that we really haven't quite gotten the entire population to pop to. Hey, people, think about things in 3D space. Because we haven't advanced the minds of man, these scientists who do think in 3 dimensions, or don't, are able to draw shitty little diagrams about how things work, and everyone believes it. For any of you who've ever dabbled in astronomy, I guarantee you there was a moment from your infancy to your adulthood when someone finally told you, you know that diagram of the universe, the solar system they show you with the sun and the 9 planets? Yeah, fuck that Pluto being an asteroid bullshit. And they said, well, you know, the sizes aren't the same, guys. If you were to draw the solar system at the scale, you would see it on even a landscape book. You couldn't see almost all the planets. You see the gas giants, but you wouldn't be able to see much else. And even the gas giants, you'd need a little magnifying glass to see it on the page. You wouldn't be able to see Mercury, Venus, Mars, Mars. You wouldn't be able to see Pluto at all. And there's that mind fuck where you're like, oh, wow, you're right. Things are a lot bigger than I thought they were. When you have the epiphany of how small everything is in relation to other big things in the universe, at least as they've theorized them. And do realize that I understand that I'm building this entire episode out of the overall heliocentric model of the universe. It still has value, regardless if that's true or not, right? So I'm going to throw one more thing into this initial episode of Crap Science, because we're going to keep it Crap Science. Volume 1 is the speed of light, and its stranglehold on the mind of man. So the speed of light is this very interesting thing in the 20th century due to one super plagiarizing, wife-beating, cousin-marrying dude named Albert Einstein. I promised 50 episodes ago I'd do an episode on him, and I'm very close to going ahead and doing that. If any of you have seen Peter Sellers and Being There, if you haven't seen that movie, Being There, watch it. It's weird. And that's Einstein. He sat as a clerk in a patent office in Europe and saw the geniuses of Germany and France try to file theoretical patents. He had his mind opened. He denied the patents, ripped them off, and just like Joseph Smith, creating his own religion in upstate New York, that's Einstein. You think, oh, that couldn't possibly happen. He's peer-reviewed, blah, blah, blah. Well, yeah, he's being peer-reviewed against other German and French designers, other thinkers. Hey, think about it. If you hadn't heard of general relativity, special relativity, or even quantum mechanics, and I right now could teleport myself back to, 1895 or whatever, just with my layman's knowledge of it right now, I would be Albert Einstein in 1 year because I could just plagiarize everything I've ever heard. I wouldn't have to totally have all the answers. And then I could spend 40 years, 50 years of my life perfecting my bullshit. And everybody's like, he's so smart. He helped invent the nuclear bomb. That's evidence he's a genius. You're like, well, he created E equals MC squared. No, he didn't. That's more of the plagiarizing. And again, he couldn't complete basic math in college. He had Rosen and two other guys do most of his mathematics for him. So how did he come up with E equals MC squared? When if you put him in front of a board with calculus, he wouldn't know what he was looking at. And that's just above ground knowledge, right? But they did create this energy equals mass, and mass equals energy epiphany of what I think the people who created the pyramids understood a long time ago. Wow. What you're basically saying in a very theoretical, obfuscated way is that we're all made of the same stuff. You genius, you. Now, what is the theory? E equals MC squared. What do those things stand for? Energy equals mass times the speed of light squared. Okay, here's my cigar, man. Take it. Now move this at the speed of light squared. Go ahead and do it. Take any object in your house right now and your car and move it at twice the speed of light squared. Go ahead and do it. Oh, you can't? Oh, well then, Jesus, I guess you can't prove that my theory's right. How convenient. I sound really smart, and you can't do a goddamn thing to prove it. Speed of light squared. That sounds really fast, by the way. It's the speed of light times the speed of light, okay? But he drops this equation, and then all of a sudden they realize if they put a bunch of very chaotic mass, like uranium, 234 and 235, into a container, which we call, we refine it to the point it's just as pure as it could possibly be, which is an atomic particle with 234 to 235 bits and pieces, electrons, that it can't hang on to itself. It's constantly emitting this radiation. Just ask Madame Curie, who died of it. And if you compress it, wow, something happens. But again, we're not convinced that stuff ever actually happened. It may just be a theory on paper, and they just use TNT to blow the shit out of everything. All right. But out of that theory, it says that if you try to move any object to the speed of light, that you will run out of the amount of mass required to push that object, and it can never achieve the speed of light. It's romantic, isn't it? That this would be some byproduct of some energy to mass conversion algorithm. When I was in high school, I took physics, and I know it sounds lame, but I had one of the most amazing teachers on planet Earth, Mr. Goering, which they would say Gehring, which is funny. He was a genius. He was an absolute genius. He's still alive. But he gets to that point in the class, and I'd already had, I guess, about 7 years of studying this on my own time. I lived in this stuff. And, you know what, I talked to him once about 20 years ago, and I was just having a conversation, just checking in on him, because I hadn't talked to him in a long time. He didn't live in my hometown. He lived 17 or 27 miles away. Something like that. And he said, you know, the most frustrating thing about you was that I'd be trying to teach the class something, and you'd start reading just off the top of your head, you'd start reading me all the paragraphs out of the books that you've read, and it was like I couldn't keep track. I couldn't keep control of the class. He goes, that was the most funny and frustrating thing about you. But he goes, the more I thought about it after class, it was a pretty cool little trick, you know? And I only say that so you understand how much I knew as a teenager. Right? This guy had been teaching this stuff for 20 plus years, probably almost 30 years. Now, when it came to the class, I remember where he's teaching E equals MC squared thing, and he goes into the limitation of this mass being able to go the speed of light. I'd read, just had crest over, and I don't even know what books I was getting into or material I was watching, because there's no internet. They didn't have a giant book collection at home stuff. I had heard some talk and some chatter about that just simply being wrong, and that by simply accepting it on a piece of paper because someone tells you, or a blackboard, all of our brains get closed, all of our minds get closed. So I raised my hand, and he's like, oh, Christ, here we go. Yeah. And I said, well, what if he's wrong? What if this entire equation is just an equation, just a theory, and it's wrong? And he got real pissed off because he's like, God damn it, I have to teach this theory the way it's been written into the history books, and you're going to be messing it all up with your question, man. And then I believe I was watching some interesting sort of home footage out of some guys out of Cornell University, some theoretical physicists that essentially had, and it's up there on YouTube probably, but Christ, it was 15 years ago. Most people cancel their accounts after a few years. But they were talking about a vortex and the fact that when energy goes down into a vortex, it starts to spin faster and faster and faster. And they had come up with a complete theoretical model that proved, using electrical energy theories that have been existing for 70 years before physics, quote unquote, started to erase all this stuff with their other theories, right? So electronic theory is observable and provable in a laboratory, whereas physics theory is just a bunch of shit on paper, for the most part, per capita. And once I saw this lecture, these kids were just filming themselves in their university in a classroom with just like 2 or 3 of them. And they were drawing these beautiful diagrams on the board and talking about what we know about how electricity works. And right before your very eyes, you saw them prove that things can travel faster than the speed of light. In addition, Eric Dollard, I'll say his name over and over and over. You got to get into this guy. He's an amazing human being. He's still alive. I hate to think he's as old as he is, because he has personally awakened us to the masters of the universe, the electronic masters of the universe. As I always say, Faraday to Tesla to Steinmetz. He built on video in 1988, and I believe what's called the Borderland Group. It was, I think it was in Los Altos or Palo Alto or somewhere in the Bay Area, in his basement with a couple other very astute gentlemen, and they did tons of experiments. Go look up Eric Dollard, ERICDOLLARD, and Borderland. It's a bunch of like VHS sort of videos, home camcorder videos. But one of the most brilliant things he does is he creates a longitudinal circuit on a table. Now, to review, a transverse wave is like when you take a rope and you flip it, and you see that wave go all the way down the rope. But again, it's like a photon. And then you have a longitudinal wave, which is when you take a broomstick and you're holding one end, I hold the other, and I go boom, and I punch it, and you immediately feel it on the other side. There's no waiting for the wave to get to you. And so he demonstrated very quickly that all the electronics in the world operate on transverse waves. This delayed thing. Now, you all know that when you plug in a string of lights, Christmas lights, to your 60 frames per second brain, that light comes on, that whole string of lights comes on instantaneously. But if you were to slow down and shoot it with one of these super high speed cameras, it's doing 1 million frames per second, it's going bink, 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 as the electron valence, the stimulation of sort of the chainsaw blade of the outer electrons on the surface of this conductive wire that's inside there, it starts rotating all the electrons. It's literally like a chainsaw blade. It just goes in circles around anything that's conductive. If you're touching something that's shocking you, it's going in a chainsaw blade technique on a conductive surface. That's why it's conductive. Gold is really conductive. Copper is pretty good too. Other things aren't. Okay? So he hooks up voltage meters, he hooks up oscilloscopes, and he starts to study the time it took for the circuit to transmit to the other side of this other circuit. And they built these beautiful circuits that are configurable. And you could turn them in one orientation and connect them all together, and you get a transverse wave. And then you turn them and connect them together, and you get a longitudinal wave of electricity. I'm going to forget exactly the numbers, but I'm going to get really close. He does a transverse wave circuit, which is what all your computers are made out of, what your phone is made out of, what the world is made out of. And I think it was about 0.82, 82% the speed of light. Let's put it that way. So everything that we're running, all the equipment you're seeing me on right now, is all running below the speed of light, sublight speed. And the reason why is that the valence, the method of the wave of electricity is in this transverse wave, which is slow, but it's also limited to the actual, resistance of the materials that we use, right? Resistors are things that slow down electricity and slow down the amount of electricity that can travel over them, right? Controlling the circuit requirements, the voltage requirements, the components that are inside of an electronic device, right? Okay. Then he reconfigures it to a longitudinal wave. And you can watch him do it. You can watch him do it on camera, okay? Then he runs the same exact test. It's essentially like light up a light bulb at the end of the table sort of thing. Instantaneously, in front of your eyes, he makes that, he doesn't personally travel, but he makes the circuit complete itself 11 times the speed of light, right in front of your face. Now, you would think that would be on the front page of every single scientific rag in the world, and that post-1988, every single device in the world would be built with longitudinal circuits. Now, it could be that we'd have to work on cooling circuits, because that, moving electrons at that speed, I don't know if it creates more thermal energy or not. Maybe it would heat up everything and melt everything. But these circuits were doing just fine on this table. They look pretty meaty. So it's almost like the difference of using silicone versus some tube technology. If you look it up, you'll find that the speed of light is measured differently all around the world, but because we have this theoretical standard of how fast it works, we just keep reporting it. Was it 182,000 feet per second or something like that, right? Super fast. Now, someone might contest, okay, smarty pants, you're talking about electrons versus my shoe. Maybe Einstein's just simply saying my shoe can't go the speed of light. Electron still is a noun in one designation of sigma 5 CERN acceleron designations, right? So it's not a ripple, necessarily. If you do study the ether model, you'll start to find out a disturbing truth, which is everything is a verb. Everything. The old analogy that I put forth in the gravity episode, which I've never heard taught anywhere else, is that when I do point at that current in the river, and I do the whole experiment with you, what is that? You say it's a current. I say, no, it's just water. But even if we both sit there and agree, yeah, you're right, it's a current. But if I put red dye a couple feet up the stream, here comes the red dye, dump a whole bucket of, red stuff in there, you see it go down into the vortex and then go down the river. Okay, the current stays right there. But it has used a renewing supply of water to create itself, right? You can't get a drain in your spinning vortex of water and the drain in your tub to just stay there and not move. It's got to be moved. It has to have a resupply of water going down a drain to exist. And that's how the whole universe works. As it is above, so too it is below. For those of you who believe in any model of the universe that is non-heliocentric, you can't deny the way that your drain works in your bathtub. So if you want to believe any other sort of religious model of the world or whatever, I assure you that these rules work all over this environment. Crap science. We've got to start undoing crap science, and we're not the first to start undoing it, even if we created a revolution as a result of this episode. We're sort of the citizens down below those that are dedicated all day long to doing it. But now let's finish the episode talking about the resistance towards crap science. Why there is resistance to crap science, the benefits of crap science to those who peddle it. We try to make a statement when we live, right? We do. We get born, we live. Some people are humble and beautiful, and they just simply want to contribute to their circle of life, their kids, their loved ones, maybe just themselves. And when they expire, they're like, man, that was a good journey. I had a really good time. I ate some apple pie once. I went to Disneyland once. That was cool. I got to see the benefits of a bunch of creative people in science and creativity and storytelling. That was kind of cool. I met a girl once that I fell in love with. I met a boy that I fell in love with. Maybe I got to end my life with them at my side. Those are the most balanced human beings on this planet, in my opinion. Those are the moments that we revere because something wonderful is occurring. Your heart gets involved. The very substructure of, I think, consciousness, which is love, swims around inside all this ethereal wind, right? But now let's just say you're a little awkward. For whatever reason, the perfect storm happened and you're a nerd. You don't look maybe right for society to accept you, or maybe you're handsome as can be, but you just can't figure out how to put clothes on. You can't figure out how to comb your hair. But for whatever reason, the stimulation that you get from a book of science is pretty much the same stimulation someone else gets from watching porn. Definitely recommend the former over the latter. And when you start to talk about all this stuff that you've memorized, you start getting accolades, you start getting rewards. People start going, wow, he or she's really smart. I watched Jeopardy in an airport the other day, yesterday, and it was interesting how you only get a score on that show if you buy into revised history and pop science, aka crap science in a lot of ways. And sure, they have a lot of factoid things that are absolutely true. Where's the Nile? who was president at this particular time, who wrote that book. That's all good knowledge, if you care about that information. But every once in a while, there'll be a category about science, and then you hear a bunch of bullshit. They're getting money in the show. They're winning the show because they're willing to answer the questions according to the accepted, quote-unquote, facts of the universe. There are dozens and dozens, if not hundreds and hundreds of stories where someone actually discovered what was really going on in this world, and they were persecuted for it. And sadly, it's in every category of life, right? You'll find people that, like Bruce Lipton, a prodigy medical student who, when he started to figure out that everything, well, I shouldn't say everything, a lot of things that he learned in medical school, when he took it to the laboratory and tried to prove it, he realized it was wrong, got excited that he had figured out that we were wrong, took it to his 10-year professors who run the place and said, oh my God, I've got this, we're going to be one of the most popular universities in the world because I've uncovered that we were wrong. And with this new understanding, we can heal people. And he was let go from the university and had to move to Guam. There are historical warriors out there who have the open mind to question everything that's ever been claimed in history. But there are 14 countries that won't let you question certain parts of history lest they put you in jail. So people have died in prison in Europe because they simply had the balls to ask a question. Others that didn't go into history, didn't go into jail, but they went into hiding for 20 years. Recently, I think they've popped out. They're still not invited to talk about what they've discovered. They've proven beyond the doubt the scientific facts about claims of history in certain pockets, certain decades of our recent history in the last 100 years. They're not being revered, but they're the smartest people on this planet when it comes to thinking original thoughts, not being indoctrinated, and really trying to write down in a book what really occurred and what really could not have occurred in history. Okay. I know you can feel it already, right? What's the difference between someone who becomes a professor in a college, having never worked in the private sector, and someone who has to actually work in the private sector and make things work? All right, well, if you're a theoretical scientist in the academia world, working as a professor, writing paper after paper about theoretical possible truths, one, you can't afford to have someone walk in the room one day before you publish your paper, which is going to fulfill one of your fiduciary responsibilities for the university to provide accolades for the university, income for the university. You can't have someone walk in the last day and go, you know what, you're completely wrong. All this pop crap science that you're basing your new theory on is just more crap. Who's going to get attacked? The guy who wrote the shitty paper that's going to perpetuate more lies, or the person that's coming in saying you're wrong? Well, there's only one of the people usually walking in saying you're wrong, and there's a shit ton of people saying that the other person who's wrong is right. Hawking made a whole life of this stuff. I'm going to give Stephen W. Hawking some credit, though. I'm going to give him the benefit of the doubt that he actually didn't believe everything that he was forced to write down, or maybe had written down on his behalf in some cases. We don't know. I saw David Blaine do a trick for him in the last 5 years of his life, and he seemed to be very cognitive in the chair. And David blew him away with a card trick. He smiled, and we watched him use his apparatus to talk, and he said, amazing. And David Blaine, and you can hate that guy, you can love that guy, but god damn it, he is one of the most amazing magicians, illusionists to ever live. Doesn't mean everything he's ever tried has been that impressive, but god damn, his street tricks, his close hand magic is second to none. Some people get to a point when they really want to be known for being smart. And I want to say that that's a fine goal to have. It really is. But I have close family members who are like this, who have literally like psychoses related to the fear of being dumb. And if you so much as question anything that they say, you'll see them melt down. I mean, I've seen people utterly melt down and try to jump out of moving cars. I'm not joking, because the word dumb was used loosely towards one of their ideas being delayed versus being enacted on. I was saying the idea was great, but I think it was dumb that they were going to delay sharing that idea with the world. Pretty innocent little statement. It's sort of a backhanded support statement, right? I think you should go for it, man. I think that's brilliant. I think it's dumb that you would hold it back. The word dumb was spoken. Let's jump out of the fucking car while it's moving. So I personally experienced this psychosis at a ultimate level. Someone almost willing to take their own life, being associated with that word in any tense of any use of the word. Bizarre. I'm willing to bet that a lot of folks would have the same reaction who have built their whole lives out of this academia world. But what happens when you have to live in the real world? And you have to make your science, quote unquote, work. I mean, you got all these theories. Shit, man, if you're just living in paper, well, shit, what do you have to prove? Eric Dollard split it apart for us, and he said, well, you know what? You can make transverse waves work on circuitry. You can. That's what everything's built out of. It's a shitty way to move electrons. You should go longitudinal circuits. But you can make it work with your bad idea. It certainly sells a lot more units of electricity, doesn't it? How many cycles of electricity do you pull from the power plant in a transverse circuit to render an image in 3D products? A lot. What if you had a longitudinal circuit and you're rendering the same thing? Oh, you're done. You're done in 1/11th of the time. Sounds like you're selling less electricity, doesn't it? We know that bankers and corporations that try to control us do not want us to be smart. They're fighting us every step of the way. If you watch Rollerball 1975 with James Caan, I did a whole episode on it you should watch. Jonathan E., the fictional character that James Caan is playing, is trying to find books that tell him how the world really works, how executive decisions are made, how the structure of the upper management of the world works. He can't get any of the books because they've been rescinded out of the library and paraphrased to keep us stupid. In exchange, the corporation says, well, we built a beautiful life for you. Why do you need to know this information? You don't. All right, that's a philosophical attitude towards knowledge. For any of you who have ever been loyal to Microsoft Windows or the Apple operating system, you'll know how this goes. Once Microsoft totally dominated the operating system world with Windows 95, they managed to get Windows 98 out, and it was pretty much really solid. Didn't crash much. It was great. Apple was being run by Gil Amelio. He was destroying the company single-handedly. Eventually, Steve Jobs comes back and says, you know what? I'll do 2 more versions of this old operating system. The last version, 9, was the worst. But I'm going to bring you my next operating system I've been working on for nearly 10 years. And you're going to love it. When he released OS X, no one paid much attention to it. Steve Ballmer said, oh, it's just a warmed over mock Unix kernel. All right. But eventually version 2 came out, 3 came out, 4 came out, 5 came out. And all of a sudden this shit started getting tight. Now Microsoft had a problem. They were way behind the curve of the internet. But that's what happens when you allow someone to dominate knowledge. They just say, well, we're forcing everyone to buy Windows. If you want to run any operating system on a Windows computer, which is 97.5% at the time, you don't have any choices, so fuck you. That's what they do. American cars got really crappy in the 70s and in the 80s. Well, Japan came in and said, we got something called Toyota and Honda, and we're going to eat your fucking lunch right in front of you. You know, when we lost World War II, when we won World War II and they lost World War II, their generals on the boat outside of Japan, when they signed the treaty to give up, to surrender, they said, we're going to take you over by all financial means necessary. Same byline of the Skull and Bones back in 1834. Both of them made it come true. Of course, we had a bunch of shills in our government handing over everything that we made. All right. To get decent science out, we have to understand crap science. We have to understand the entire mechanism of crap science. People living in theoretical models versus people living in the real world. If you want to sell me the iPod 2.0, some amazing new invention that does music and gives me a 5-cent brainstorm session with my music, you're going to have to make science really work. Anyone who's ever been sick with cancer, you won't pay attention to this pop science, crap science thing until you're sick with cancer. And you visit your oncologist and they tell you that, okay, you're going to really hate all the methods we have to cure you of cancer. Why don't you go to the internet and start searching on B17 and the Gershom technique and thermal techniques and vitamin C and all this other stuff, all these means that will absolutely cure you of this stuff, depending on your stage of cancer, of course, and your dedication to the regimens. You realize you don't have to lose your hair, you don't have to puke your guts out, and you can get cured, fully cured. Like no more in your body at all. But it's super sobering when someone in your family dies of cancer. Super sobering. I think most of you would agree that man on Earth is a very special creation. We'll perhaps in the next volume of this episode go after evolution and the something from nothing theory. It's in a lot of my episodes, okay? But if we're to preserve this actual byproduct of man that is supposed to be amazing, we're going to have to get off our lazy asses and start taking an active role in knowledge. Most of you listen to the show. You're doing it every single day. I'm preaching to the choir. I'm trying to give you guys some more sort of scientific thinking theories and open-mindedness to go on your own journey, to bring in a lot more disciplines than I will ever cover on this show. If we're to rebuild this society from the ground up, we're going to have to start thinking again. We're going to have to start rejecting paradigms of restriction, because that's what academia brings us, is closed-mindedness, not open-mindedness. How many times have you heard papers you've read them in magazines, you've read them online, where they say there's all kinds of dimensions to the universe. We're up to 30 dimensions of the universe. And you're like, man, that sounds really cool. But when I walk in the room and I go, what do they mean by dimensions of the universe? Tell me, professor. They're like, well, I don't know. They're out there. Make sure you're not that guy, you're not that girl. If you want to start passing around these pop science theories of dimensions of reality, explain it to me. What do they mean? If you read a paper, what's funny is you can read an entire 4-page article in Scientific America about dimensions of reality, and at the end of the article, when you see that little square, a little black square, it says that's the end of the article, you have no clue what they were talking about the whole time. And you could have a PhD in all the disciplines of that science, and at most you'll have some sort of apparition of what they were talking about in your brain. It sort of felt real. I mean, they definitely used the standard jargon from that era, from our era, I feel like I'm smarter. I've never had a conversation where someone talks about the dimensions of reality. I had one the last month, talking to a very brilliant man, and he started, we have we're up to 30 plus dimensions, 33 dimensions or something. Oh, that's very Masonic of you. But when I said, well, what do you mean? Nothing. Zero. Not even the first inkling of what the hell he was talking about. But I'm willing to bet that conversation happens once every 2 weeks out of that guy, because it makes him sound smart. He's already talking in words that are sort of above the intellect of most people, but he doesn't know what he's talking about. He's doing Jeopardy. What is 30 dimensions? Don't be that person. I think you feel me. I could talk forever on this subject. I love this subject. If you haven't been to deepthoughtsradio.com, please go. There's a locked Facebook group. There's audio, video, and a Patreon page. Take care of yourself and someone else, and I'll see you in the next Deep Thoughts. Over now.